Assalamualaikum and hi, my name is NAJWA binti SYRAJUDDIN and my metric number is 153939.
Assalamualaikum warahmatullahi wabarakatuh. My name is AIDIL OSMAN. My metric number is 153111.
Assalamualaikum and hi, my name is SYAHDATUL Farhanah binti MAZLAN, metric number 153955.
Assalamualaikum warahmatullahi wabarakatuh and greetings. My name is AMISYA SURAYA binti RAMLI. Street lights are built with an automatic system where it will light up during the night time or on cloudy days. This is possible to happen due to a photoresistor named LDR, light dependent resistor. LDR is a resistor where its resistance varies with the amount of light falling onto its surface. The mechanism of LDR is when it detects high intensity of light, the resistance will be low and thus there is current flow. In contrast, when no light is detected, the resistance will spike up and the current will not flow through the LDR. In this project, we use Arduino Uno R3 to control the circuit. The programming has set a few threshold values for the resistance, which stand for the intensity of the light. The microcontroller and then will read the input and produce what has been called.
Problem statements. Global energy consumption is increasing rapidly from time to time. However, the source of this energy is limited. Even if it is difficult to secure an energy source, it is necessary to make appropriate use of existing energy sources. The explanation for our problem is how to use automatic control without the energy waste of street lights due to manual control of these lights. The solution is light-dependent resistor (LDR) or called as photoresistor is used to demonstrate how the automatic street light works without consuming a lot of energy. The trigger of the photoresistor depends on the amount of light around it. When the ambient light hits the photoresistor, the street light turns off, while in the absence of light, the photoresistor turns on the street light. We can also know the general intensity of light by using Arduino and some coding in the software.
Next is the components used in this project, which is the first one is Arduino Uno, USB 2.0 cable type A and B, photoresistor, LED, resistor 220 ohm and resistor 10k ohm,
male-to-male jumper wire, and lastly breadboard.
Okay, so next is the circuit build, the light intensity test and the circuit test. Show you the circuit build using the component we just show you just now. And then the last step is we connect the wire into the adapter in our laptop to do some coding in the Arduino software to test the intensity light, and the final is the result of the circuit test. Next is the light intensity test. Like I said just now, we do the light intensity test to know whether the light is follow the rules or not. So in the screen, this is our coding to test the light intensity, and in the right section you can see the analog reading and the number shows the light intensity. If the number is lower, the light intensity is lower. If the number is higher, the light intensity is higher. So in the screen, it shows the light intensity is higher. It's higher when we don't close the box. It will be lower if we close the box. If we close the circuit by the box, and it will show dim in the analog readings, it shows the light intensity is lower. Next is the circuit test. In the circuit test, we close the circuit by the box. If we want to know whether the LED will light up if we close the circuit. So as you can see, the LED is light up when the surrounding is dark. When we open the box, the LED is shut down because the surrounding is light up by the light.
Next is problems encountered. First one, LED did not turn on when dark because of the wrong connection. Second one, polarity of some components like resistor and photoresistor is unknown. And lastly, the sensor sensitivity, which is photoresistor sensitivity, decreases. To encounter the problems, we come up with a ways, which is the first one is to recheck the circuit and make sure the connection is correct. Second one, we search through the internet about the component's polarity. And lastly, we switch off the connection when not in use to maintain the sensor sensitivity.
In conclusion, photoresistor can really save energy consumption. Other than that, it is also cost-effective and sustainable for our one and only the Earth. Photoresistor is a very useful sensor and has a variety of applications. Besides streetlights, it can also be used in alarm devices, light detectors, and many more. And that's all for our presentation today. Thank you.